This is the Science Department's e-learning wish list. The main requirement that the Science Department had for technology going into the future is that the students must have quick, easy access to the technology. It must open up and be running immediately. The applications must be quick and easy to use. And on top of that, the students must actually want to use it. They should not have to worry about forced reboots, software updates which take whole lessons, whether the technology will work at all, and whether the software that was on the computer last year will still be there now. We would like students to be able to turn the device on, launch a browser, and do whatever sort of research they want instantly, quickly, no fuss. In the same way, we want the girls to have that instant access to the daily notices, so they should be able to open up their browser, pop in their login details, and have access to the notices. We would like our girls to have quick and easy access to their textbooks, so they should be able to just flick through, annotate it, but it all has to be quick and easy. They should be able to flick through and go to whatever page they want to. They obviously need access to their files, so they should just be able to go in to whatever files that they want to have a look at and have quick access to them. Basic functions such as word processing and spreadsheets should also be just very simple, very easy, and preferably automatically backed up. The Science Department would actually prefer students to handwrite their notes in a book, and then if they wish to have a digital copy of that, then apps like this one allow the work to be quickly and easily digitised and turned into a PDF. We would like students to be able to do quick and easy annotation of photographs. So for example, in a practical, they should be just able to quickly take a picture with their device and annotate it appropriately. The Science Department is also interested in curation. For example, when I'm doing my web surfing, I often come across articles that I'd like my students to read. So this particular app, Flipboard, easily allows you to create a specific magazine for a class, for a group, and you can again easily add articles that are of interest to you, that would be interest to them for the topics that you're doing, to be popped into a magazine. We would like our students to be able to do simple video analysis. So for example, this particular app allows us to do frame-by-frame analysis of a collision. So if we're looking at a concept such as inertia, it enables us to very simply show that this particular object, this particular little person, has inertia, the other trolley is knocked out from underneath them, and they are staying effectively where they are. That sort of thing needs to be simple and easy. We need the girls to be able to use the data logger technology that we have, and once again, that just has to work. We need to be able to open up the application and be gathering data quickly, easily, without having to worry whether the technology will actually work. We'd also like to be able to do simple things like digital storytelling. So this is just a little cartoon I set up. Obviously this is just one for this particular use, but we'd like students to be able to do this sort of thing and tell a story about science, explain something to do with science using digital storytelling. We would like our students to be able to make little tutorial videos explaining a concept. So for example, this is one I did for chemistry.
Enter
into a solution of copper sulfate, what happens is the actual zinc gets this lining across the whole surface, not just around the edges as shown in this diagram, gets a very thin layer of copper being deposited on it. That sort of process really should be very simple and easy for the students to do, and once again, shouldn't be any big deal. We'd like our students to enjoy doing such simple things as looking up words. So for example, this word, or this dictionary, is called WordFlex. I'll look up the word wonderful. What we get, these word clouds, an enormous amount. I've picked a word which has got lots and lots of things in it. Let's pull this back. But we can actually zoom in and get some different words that all mean wonderful. It's informal. We've got North American informal, Australian, New Zealand informal, etc. So this is pulling in from the Oxford Dictionary, and these sorts of things can also be used to make wonderful title pages and things like that. Fun. Mind maps. Let's have a look. This is a mind map I did last year as an assignment. And it's extremely easy to make a mind map. And I actually printed this on A3 and then got the students to use this as their assignment. But in terms of actually making mind maps, astonishingly easy. Let's talk about atoms. Okay, we're going to go made up of protons, electrons, neutrons, etc. You can see how easy this is in terms of doing a mind map. We want that sort of thing to be quick, easy, and again, not a big deal. We'd like to be able to pull up information from excellent sources. So this is an atlas, so we can pull up just a satellite map, we can pull up physical maps of the Earth's surface, political maps, energy. Let's just have a look at energy. Now with this particular app, I'm going to look up the energy consumption of different countries around the world. So here's energy reserves, so it just pulls up, so you can actually just go across, just shows different information. Energy production, I'll look at energy consumption, and we can compare Australia's consumption to other countries. Etc. We can look up energy production. Okay, we can pull up some more information. We'd like to be able to draw diagrams easily. These are some ones that I've done for chemistry. And again, these are, and I am not an artist, but these are just functional, quick, easy to do diagrams. We'd like to be able to use astronomy programs. So for example, here we go, we've got the Southern Cross shown here. Zoom out a bit, and what I'll do is put it to hour, actually I'll go to a minute, and I'll play. Now what's the big deal about this? Well, the big deal about this is the fact that we can easily see that the Earth's rotating, and as we do, the sky is rotating. We can also find out what is, or information about various things. We can do tonight's best objects, find out what is visible, where it is, etc., and zoom in, and we can then use that for astronomy purposes. We'd like to pull up information about earthquakes. So this particular app pulls in all the recent earthquakes. We can pull up specific information. Okay, sort by date, sort by magnitude, etc. But it's short, it's sweet, it's highly usable, and we can get quick information. We want to be able to do cool stuff that the kids go, hey, fantastic, check out that. We want to enthuse the students with our subject, and our technology can help do that. Got physical data there. If we're discussing the human genome with our students, well, how cool is it the fact that I can pull up eye colour and actually show which chromosomes have genes which pick for eye colour. Isn't it cool that you can just pull up information, for example, about the human body? We can zoom on different bits. Let's pull up the veins. Look at the veins. Let's close that. Pull up the respiratory system. Let's zoom in. Can't really see what I want to see, so I'm going to click there. I'll fade others, and then I can show different parts of the body in more detail. And this, I can pull up the digestive system on top of that. This is all just wonderful stuff. How about straight things like microscopy? Let's pull up some digital microscopes, or electron microscope scans of different organisms. We'd like to leverage the technology that the kids use at home for science purposes, in particular for educational purposes. This is the sort of technology that they use. We'd like them, when they're bored at home, to just pick up, do some of their science, do some of their English, do some of their music, just on the technology that they already use. The science department would like to use augmented reality. For example, on the wall here is a poster on the element boron. We'd like the students to come along with their devices, and once the device is pointing at that particular image, in this case it's playing a video all about the element boron. If they go and look at another particular poster, they'll pull up the information about that particular poster. We can imagine a place where, in, for example, art, students go around with their devices, they point their device at a piece of artwork that a student has done, and you might have a slideshow showing the stages of development of that particular artwork. That's just one example, but we would like to be able to use augmented reality simply and easily in the science lab. We would like to be able to use our technology as document cameras. For example, we'd like to be able to get a student's work and display it on the data projector. And in the same way, we can use it to demonstrate particular practical techniques, simply and easily, so that all the students in the classroom can see. In summary, the technology must work immediately, infallibly. It must be quick and easy, must be fun and encourage learning. It must move beyond substitution and augmentation, and it has to be something that the students want to use.